Today we're here with Denise Bolte. She is the Senior Laboratory Technician at the Veterinary Diagnostic Laboratories. So thanks for being with us today, Denise.
Thanks for having me.
Very good. So we're here at the Bacteriology Lab. Tell us a little bit about what you guys do here.
Well, here in the Bacti Lab, we get in samples from all around the country, and we get things from wounds and urines and fecals, and we're trying to figure out what's going on with the animal that may be bacterial based.
How many samples do you guys run through the lab in a day or a week? Or
we get about 100 fecal cultures a week, and we probably get about 100 wounds, urines, and miscellaneous type cultures a week. So we're fairly busy here in the Bacti Lab.
I was going to say, because it's not a 24-hour test for you. You guys are, it takes a little bit longer to kind of get to the end result, right?
Right, yep. It takes about 48 hours, and for some things like anaerobes, we hold those for 5 days. Fungus, we hold for 4 weeks. And mycobacterium, we hold for 16 weeks.
You have samples coming in from all over the country, I would assume, right? Why do you think people are doing that?
I think people come to vet school here at Colorado State, and they know it's a good school and that we have good services, and so they send their things back to us. And then also word of mouth. We're a very highly accredited lab, so we have a lot of good feedback from our clients.
You talked a little bit about the process as a sample flows through. Once you've got the results, then what happens?
So once we send our final results out to the client, then those go, of course, to the vet, and then the vet can look at those and look at clinical signs that the animal may be presenting with,
right,
and take that information and make a treatment plan. So maybe we didn't grow anything, and maybe they have to go back to the drawing board, but maybe we grew bacteria, and they have an antimicrobial sensitivity, and now they're able to treat with the appropriate drug.
Now's a good time maybe to take a look at some of the samples that you guys have been, or some of the specific tests that you're doing.
Yes, let's go take a look at where we set up our samples. In this lab, we are doing our sample setups. This is where we take all of the samples that are coming in for the day. So we have swabs and red top tubes with urines and fecals, and we're going to plate those on our 3 bacterial growth augers. So we have our blood auger plate, and that is our general growth media. Most bacteria will grow on there. We have our Maxinkuckee plate. That's going to grow our gram-negative organisms, such as E. coli, but it will grow bacteria that are more difficult to grow, like Bordetella or Pasteurella. So once the samples are plated, then we will streak each plate for isolation so that tomorrow, when the plates are read, we're able to actually see if there's one bacteria growing or multiple bacteria growing on the auger plates. So now we're in the Bacti walk-in incubator. This is a 35-degree incubator, and that's where all of our plates go for 24 hours. And after 24 hours, we take them out and we look at them to see if anything has grown on them. Like on this plate, we can see that there's bacteria growing. And we have different augers that tell us different things. So this one's turning yellow, and this one's nice and pink, which tells us it's a gram-negative lactose fermenter. So this is our MALDI-TOF mass spec, and this is our newest state-of-the-art bacterial identification system. We place our bacteria on these slides. Each spot is one bacteria, and we just take one colony, put it on the slide. We put a buffer on top of it, and then it's going to go into the machine. So in the machine, it has a slide holder, and we just place the slide into the holder, and then it will go into the machine. And what this machine is basically a big vacuum, and each bacteria has a unique ribosomal protein, and that is what the machine is going to read to identify each bacteria based on a spectrum based on that ribosomal protein.